Before I begin, let me ask you a few questions, just to get to know you better. I won't ask you about the Go experience because we've been asked about that a couple of times already, and I believe it's going to be tiring after some time. I have a different question. Who of you are developing your own product? Something that you built, not that you're building something for someone, but you're building your own product and you're selling. Okay? Few hands, or maybe who of you are building anything really that you need to have some public documentation for? So some public library or anything that you want to share with people so that you don't have to explain everyone how to use it. And who of you would like to have that documentation generated automatically? Okay, I'm not going to help you with that, but maybe my talk will make it a little bit easier for some of you. And the last question: anyone here who thinks that it's okay to put the pineapple on a pizza? Okay, I see some brave ones. Good for you. Okay, this is everything I wanted to know about you guys. I think that you deserve, since you spent some time with me right now, you deserve to know who I am. So a few words, and since I have a slide about me already, so let's do it. I am a blogger at My Code Smells. I am a Go developer at Ingrid. I am also a co-organizer and speaker at our local meetup called GoVrots, and also I do some sports. I run marathon 3 times. And also I am a millennial, and if you don't know who a millennial is, if you ask a question to a millennial, they will not give you the answer straight away. They spend like an hour or two looking for a perfect GIF or a meme to sum up everything that they would like to answer. Though that's basically me. So before we begin, we need to understand what the gRPC is. So maybe start with a name. So gRPC stands for, and this is rather unfortunate because I'm not a fan of solutions like that, but it's a gRPC remote procedure call. So it's a recursive acronym, which I personally hate. So if you hate it as well, you will hate. Yeah, this is exactly what I mean. So gRPC joins the family of PHP and YAML, which is a fun fact. I found about that while doing the presentation. That YAML stands for YAML ain't a markup language, which actually is a change from the original meaning with yet another markup language, which is rather funny to change the name of the acronym while it's already new. So it's like creating a Facebook group with funny cat videos and then renaming it to something like Java is king or something. And you're subscribe to that, and you don't know why you are. So gRPC consists of, in my mind, of two main blocks. The first one is protocol buffers, and the second one is the HTTP2. Protocol buffers are optional, but they are, I think, that by far the most popular choice while building solutions with gRPC. And the protocol buffers serve 2 purposes. They define the messages and how they look and what data flows one way or the other. And the second is actually the way to encode those messages into from some representation in your code base to some ones and zeros, so the bits and bytes that are sent over the network. And the second building block is the HTTP2, which is actually the protocol, the binary friend of the plain old HTTP 1.1, which supports many more stuff than the old one. I will not dig too deep into that. I know that there are plenty of excellent talks and sources on the internet to explain more. So basically, gRPC is a way of communication between two services, two applications, whatever you wanna marry. And in order to take this quick journey with me, we will need 4 things, basically. We will be using protocol buffers. So as I mentioned before, we'll be using Go because it's a GoLab and it has to be Go. But also I would choose to use Go as well. So this is the second step. The third step is Swagger, which will be used for generating documentation. And the last part is Postman, which is a very useful tool, and it may help you with, even though you might not really know that it might. So first of all, we start with protos. So the definitions of the messages. I will be showing how it would work for a simple server that will be calculating the power based on two numbers. Also, the side note, I was thinking about doing the live coding, but on the scale from 0 to Kelsey Hightower of a level of confidence, I'm pretty close to 0. So sorry about that. So we define the actually, even if you don't have any experience with protocol buffers, by reading that, I think that you should perfectly understand what we are going to do. We are creating a server with one possible call called calculate power. You have a request, you have a response. You can predict what is going to happen. With protocol buffers, we have the proto compiler, proto C, with some plugins installed for generating Go code. We can run some magic command, and then we end up with pretty large Go file, which consists of multiple blocks. Among others, there are the struct definitions for request and response, and you can see that those are exactly the ones that we defined in the proto file. Apart from that, we get something extra. We get the interfaces for server and for the client, and also one more thing, that we get actual implementation of the client, which just needs the connection, the network connection, and then it could act as already working client to our gRPC server. So once we have the interfaces, I think that it's pretty obvious that the next step would be to implement something that fulfills them. So the next step is creating the gRPC server. And how we do that? We just basically create some struct that will fulfill the server interface generated from our proto files. So since I try to limit this to the least amount of code possible that will work somehow, so this is the most basic implementation. We use math package. We calculate power based on those data that comes in the request, so base and the power values. Also, there are two ways to access the attributes from the request: directly by dot notation, so request dot power, or with getters. And the getters are safer because right now, when you call request get power, it first checks if the request is nil. If it is, then it will return the 0 value for the type that you're looking for, which is very useful if you have like parent and child and some nested structures. You don't have to do the nil checks. You just call getters and you are safe. And then once we have the server with that fulfilled interface, we need to expose it somehow. So we are using the gRPC libraries. That first we need to have the network listen on some TCP address. Then using this listener. Next step is creating the gRPC server, which is something that is provided by the gRPC library. Once we have the server, we just register our implementation of the interface to that server. So it's basically something like adding the HTTP handle func or handle to the server. And then once we have that, we use the listener for the network connection, and then we start, and this is all, and the application is ready to respond to your requests. Next up is client. So because we have the server, it's not very useful if nobody can use it. So as I mentioned before, the gRPC, the protocol buffers, and the proto C allows us to generate the client code based on the gRPC definitions. So that the only thing that we actually need to use it is to have the network connection that actually points at the address that the gRPC server is running on. So this is slightly more complicated, but I think that given the fact that the code is generated and ready to use out of the box, it's not that big of a deal. We have the new Power client, which is the function that actually provides us with the client instance. In order to do that, we need just to call the address, so the location, wherever our gRPC server is running on. We add something like gRPC with insecure, but we will not be using. We'll change that in the future. Just to point out that gRPC forces you to explicitly say that you don't want any TLS if you don't want, but you do. But for the first example, let's say that we are crazy and we don't want to do that. And then the next step is calling the functions that we defined in the proto files. So with 2 arguments, the context and the request struct. Context allows you many things. For example, the cancellations or whatever you know about context. It can make your life a little bit easier with gRPC as well. You call it, you get the request, we get the response, you get the error. You can check the errors. You should. And also, obviously, you can see the results of our calculations. So we didn't use TLS in the previous example, but we really should have. Also, a side note on the HTTP2 and TLS, because the HTTP2 is the transport layer for gRPC. This is common misunderstanding that HTTP2 enforces TLS. It does not. The popular belief is that because all the major browsers decided not to support HTTP2 without the TLS, which is awesome, I think. I'm a big fan of HTTPS everywhere, and yes, this is a side note. Obviously, also Go automatically upgrades your servers to HTTP2 once you are using TLS. Which is also a side note because the gRPC itself doesn't use the standard HTTP server from Go standard library, but still something worth knowing, I believe. And then you should basically use TLS everywhere if you are able to, because it's better to be safe than sorry if someone wants to attack you, even though you think that you are not doing anything that is worth attacking. So in order to, for development purposes, we can safely generate the certificates ourselves. We can obviously use some third-party entity that can provide us with those certificates. But again, for development purposes, we can safely do it ourselves. There are, I believe, a couple of options here. I'm not an expert on security, but there is a sample command that can generate the RSA key. And also, we add to the localhost as the domain name for the certificate, which I'll refer in a while, in a second. Basically, we can generate the files. Then we can use them to create so-called credentials, which are passed to the gRPC server. And right now, when you do that, our gRPC server is secured. So in order to access it, you need to have the certificate as well. The rest stays the same, so you basically create the server with those credentials. And of course, the implementation of our business logic is not affected at any level. And then the client side, you also create something called credentials from the file. The second argument is empty, and this is something worth noticing that by default, if you don't pass any values at the second argument, you tell gRPC that you want to connect with you say that this certificate is valid for localhost. Sorry. So for example, if you are forwarding the ports from some server somewhere, and its certificate is valid only for that particular domain name, you pass the domain name here so that you override it because you forward the server to your local host, but then even if you are connecting with the local address, you need to say explicitly that it's actually not localhost, it is something else. Trust me, I am an engineer. So and yes, and apart from that, and right now in the code snippet, you can see that we don't have to write the with insecure option. We just call the gRPC with those transport credentials, and the communication is secure. Next step will be testing, and I'm a huge fan of testing in general, and having everything tested, and making sure that everything works as I want it, and making sure that anyone doesn't break anything that I did, and especially that I don't break anything that I don't fully understand, and my change might break some things that is not visible for me. So testing gRPC handlers is pretty awesome and pretty simple, if you can say that testing is simple, giving the unit testing talk a few moments ago, which explained that it's not always like that. Basically, with gRPC handlers, so that the functions that implement those the things that we define in the proto files, you have 2 input arguments and 2 output arguments or output parameters or results. So that as long as you can mock everything that your server depends on, it should be pretty straightforward to see if your gRPC handler behaves as the way you want it to. And also, since we have the gRPC client available to be generated straight away, writing integration tests is very simple as well, because instead of calling some functions on the server, we call those exact same functions on the client implementation. I can go back and forth, and you can see that those tests look very similar. Yep, I think so. So we have the gRPC server, which is fine, but what about the HTTP APIs? So gRPC is cool, but unfortunately, it's not popular. Maybe yet. Maybe it will not be ever. Probably it will not be ever as popular as the HTTP, and the APIs done that way. Also, clients still prefer. Clients still prefer the HTTP API because they are much easier to use. But the thing is that it's difficult to maintain 2 APIs at the same time. So we would love to have something that allows us to build the business logic and everything in gRPC, which we find pretty convenient, but at the same time have those endpoints available via HTTP. And this is where a gRPC gateway comes in. This is the library that translates the gRPC endpoints into HTTP endpoints without you having to do anything really. So first of all, I said you don't have to do anything, but start with saying what we actually have to do. So it's maybe not very fortunate I said that. First of all, we need to tweak the protos a little bit. We add something called option, which basically says, again, I think that this is pretty self-explanatory, that we have the calculate power handle, that we would like to have it exposed on the /power endpoint, and also we say that we want it to be a get available via get HTTP method. The second step is also slightly more complicated, but if you remember the previous one, the way we called the proto C, we only add the dependency for that option to be allowed to be so that the proto C compiler understands what the option is, and then we add the gRPC gateway plugin so that we generate yet another, because there will be a second file with the Go code, also very long, but fortunately you don't have to like dig deep into what the file consists exactly. What it allows you is yet another function that you can use. The PB here is the alias for the proto files. We use it generally across our code base, and it's very popular. So the register power handler for endpoint is something that is generated by those in that code from proto C. And how it works is that you don't actually You don't actually have the second separate server. You just create the HTTP server that inside makes a gRPC connection to your gRPC server. So the HTTP API just takes the HTTP, the JSON structures that are the requests. It transforms it into the gRPC request, and then while it's connected to your gRPC server, it sends the request directly to that, gets the response, and again transforms the response into JSON. So that in order to run this HTTP API, the server, you actually need to point out where is your gRPC server, so that it can connect. And so, for example, you can have it on separate machines or something like that. However you wanna build your architecture, as long as there is a connection between the HTTP part and the gRPC part. And once you do that, you can call the server that we expose. Yes, we expose the HTTP server. The HTTP address, for example, is 8080. So that once you do that, you have the gRPC server running in the background, so to speak, and then you call the HTTP API with the /power. Then we provide both base and power as the parameters in the address, because it's a get request, and you get the JSON response, which allows us to build the gRPC server. But then we hand to our clients we hand actually the HTTP API. Which is fine, but still we need some form of documentation, and this is something that is very difficult to do, and nobody wants to do it. And as much automation as possible is really appreciated, I believe, in the world of people that are exposing those, that have to expose those documentations to the clients. So we have something called Swagger, which is a very popular JSON, the JSON representation of the API, so that you can, for example, it allows you to generate code, the client code for the APIs you have. In order to have the JSON representation of the API, you actually just need to add yet another switch to the proto C compiler command, which generates the Swagger JSON file based on the proto definitions that you defined in the first step. Once you do that, you have the Swagger JSON file. You can either host it next to your binary. You can inject it into your binary with some Go bin data, however you want to do it, and then you can expose that file on the same HTTP server that is used to actually to serve as a front end to the gRPC, so that our HTTP API. And again, if you do that, you obviously can ask for that Swagger JSON file, and you can see this, there is a part of the response saying that we actually have the /power endpoint, and it's called calculate power, and then some definitions of the input parameters and possible some expected output. This is not enough, because we can actually, using the Swagger UI, which is something that since Swagger is like a ready product, and it allows you, it provides you with some templates with the HTTP and the styling, so that once you take them and then put it in your project, there is a special file in the special place in that template saying, please point me to your Swagger JSON file, so that you can inject. Since JSON is a JavaScript object, you can just put it. Put it in the template, so that it acts as a JavaScript object. The template reads it, and the output is that you can actually provide your clients with something like this, which allows you, for example, to give you give this page to your clients and say, okay, you can put the values actually on the page. Click the button, and then you see what is the expected response. It also supports some authorization or or whatever you actually anything that your clients actually would need to use to see how your API works. And also, if you add some comments in the proto definitions, the comments go here as well, so that the /power endpoint is not just /power, but you can explain, put some definitions here, so that your clients actually know what that does. And the next step is run Python. I was thinking about run Java, but I've been Java developer some time ago, and I really didn't want to go back to that time. So why run Python? Because not everyone is using Go, and based on the answers you already given a couple of times, saying that you are not super experienced in Go, I assume that you do something. So whether you come from a Python background or Java background or anything, you know that you have some APIs, some HTTP APIs, and you want to have the client for that API. You don't want to do it manually and see what are the parameters, how you can tweak it, and so on and so forth. So another thing that is that we also this works for developers that are trying to integrate with you, and also for the QA, because they want to test your APIs, and we need to appreciate QAs, and I'm not saying it because my wife is one. To do that, we will be using the Postman, the tool that I mentioned before, which is pretty powerful. I've never thought about Postman being the code generation tool, but it actually is. What you need to do is you point this Postman to the location of your Swagger file, which we exposed before, and based on that, it generates collections so that you can call the API from Postman. You don't have to build any code yourself. But apart from that, you can actually use the code generation tool in Postman, which, as you can see here, there are plenty of choices, plenty of things to choose from. Apart from among those are obviously Java and Python and curl, which is probably the most popular one, so that you can just take the snippet and give it to the person next to you and saying, okay, call that and it'll work. So that you don't have to explain them how the API works. Just send them the command or something like this. So we can choose Python to do that. If we do that, we get the small snippet of a Python code, which you can see is basically all that you need to do to call the API that we just built. And if you put it in the file in the Python file and you run it, just as simple as that, you have the results. So the API is actually working. Yep. So to sum up, what we actually saw here is that we took just a few steps. We started with some proto definitions, which were fairly simple. We, with proto-C command, we generated the server stubs. We generated the client code. Next, with gRPC gateway, we allowed our gRPC server to be exposed via HTTP. We allowed ourselves to serve documentation, which is as long as you put it in like your tool chain or something. On every change of your gRPC API, you generate the documentation again, so that you expose the documentation and have it generated at least partially. And then with Postman, we allow the QAs to have the way to test our APIs without asking us constantly what did we change. And then we generated the client, so that people from other languages or from any third parties that are integrating with our APIs, they can safely integrate with what we actually did. Thank you.
Are there any questions? Thank you. How does the generated HTTP API, or does it do it at all? How does it handle streaming responses from the services in RPC?
We have a few services that actually handle streaming. I'm not super confident on how they work, but it actually does work. I'm not don't want to lie to you, so I just say that it works, but I have no inside knowledge and some tips and tricks.
Okay, thanks. And another question: do you know if gRPC will be supported by browsers in the near future? Because I tried gRPC Web and it didn't work very good.
I've heard something about that. I've never played it with it, and I think that someone mentioned that to me that it already works, but I'm not sure. So.
Okay, thanks.
More questions?
Hi. I saw a Swagger UI package you were running to serve the documentation. I found one made unofficially. I don't know which one that is that you are using there.
Actually, we just take the templates and then we do it ourselves.
So it's a custom built one?
Yes.
Okay. And is it open source?
I don't think so, but maybe it will be.
Maybe you should open source it?
Maybe we should.
Thank you.
More? Okay then. Thank you, Paweł.
Thank you.